Today I want to code a little thingy like a touch typing trainer, something like monkeytype, monkeytype.com, where you type things and then it tells you whether you're wrong or right, and um, in the end it gives you some nice stats about how fast you're typing, who may also, and I'm really bad at this, and that's why also I had this idea, because earlier this year I bought myself a little treat, a little keyboard, split keyboard, and I never learned how to touch type in the first place. So I started training on one of those apps, and I just was always wondering how hard it is to implement one of those. So obviously, what I can achieve in the next 2 hours will not have the feature all of those, but I just want to see if I can recreate the main. How do I type again here? The main UX where I type something and I get some stats basically. So yeah, I'll do that. Of course, I'm using Elm again, my trusty language that I prefer to build any UIs in. We'll have no server to start with. It will just be a static HTML page with a static or with a not so static JavaScript file that is compiled from the Elm language. So yeah, maybe I increase the size a bit. So monkey type is already taken, but since it's the inspiration, let's give a little tip of the head to them and call it primate type, primate, maybe primate type. That's a nice catchy name, I guess. So let's make a new directory, primate type. As for my previous projects, I just create a dist folder. Let's go into the primate type first to hold the static assets that we potentially deploy. But I think in the last 2 weeks, oh no, actually only for the first one, the Minesweeper, I set up a little GitHub action which deploys the content of the dist folder to GitHub pages, which is really nice. So I'll just keep up this pattern. So let's start by making an index HTML in here, index HTML. And we go straight to the guide, and the guide has all the boilerplate we need to actually embed the Elm application in an HTML file. Just the doc type declaration is missing, and I think we're going to go with a named app here, primate type. The main module will also call primate type, and then yes, we want to replace this div. So we are loading a JavaScript file that we haven't created yet. We have a placeholder DOM element here, and then we are using our Elm application to replace this with our actual app. So that should be good. Create a new primate type, open the index HTML, open the dist index HTML. Here we go, nothing to see. We should have an error that Elm is not defined because we haven't compiled the primate type JS file yet. So let's initialize an Elm application in here, Elm init. Yes, I want the Elm JSON files. Now we have the source directory, which is empty, and the Elm JSON. So let's open source primer type.elm, primate type.elm, and we just grab one of the examples here, the HTTP example, and we're going to rip out all the HTTP stuff, but the skeleton for the app is close to what I want, so just add the module declaration, primate type, exactly, remove everything HTTP. So in our init function, which sets up our application states and potentially issues a first command, we just issue no command. Let's see how the application state is defined. It's one of these things that's all useless for us. I think I'm going to set up the application to have basically like 3 screens. One menu, one when we're typing, and one results screen, and we're just shifting between those 3. So let's give it a field here, which is our focus, to let us know what we're focused on. Which of the 3 pages. Can also right away define the type. So we're either on menu, on lesson, or on results. And I want a nice view transition, like sliding between those screens. So I always have to render all of them, or at least the 2 between we're transitioning. But I think I'm just going to go with all of them. The messages, those are the type of actions, it's called in Redux, for example, that we can send from our view. For now, we don't want any here. We want to initialize our model with focus on menu, exactly. And our update function, that's the function that looks at the messages that get sent from our view and then calculates or updates the new application state from that. Do I have, I'm just going to, this focus I don't want. Let's just remove a few things here. These comments we don't want. Ah yeah, this record here, this is actually an alias because it's not a new type. It's just a new name for a record that has this focus field for now. All right, a few less lines here as well. That's all good. And now the auto formatter works also. I'm just going to clean up a bit more. We don't have this. Let's just jump to the next. I'll just jump from LSP diagnostic to LSP diagnostic. 18, this is the type has an uppercase. 25 has a space too many. Next diagnostic, of course, in our view, we don't have these, we cannot use this part of the model. We'll just start with a nice main element, no attributes. And then let's say we start with the menu, then the lesson, and then view results. Then we're going to implement those. View menu. Exactly. Boops. Pre-y pre. Diff. Please import. Add the import for me. Exactly. This gets the idea. I'm very sure there's only ever one menu in my application. That's why I'm feel comfortable putting that as an ID here and for CSS. And then we just let the LLM fill in the blanks. That looks very good. We are not using the model, so I'm just replacing this with the underscore to let the compiler know that is intentional. Hey, master user, USAYD or USAID? You said, I don't know, but thanks for stopping by. Yeah, I'm just starting fresh here, so now I have basically laid out the principal basic Elm applications with my 3 divs, and so I'm going to compile it for the first time. To compile it, we're using the instructions from the guide here. So by calling elm make, we can turn our elm application into a JavaScript file. So we're going to do this, and I'm going to turn my elm application into a JavaScript file that's also in my dist folder, so that my co-located index.html can actually reference to it relatively. So let's do this right away. Elm make source primate type minus output equals dist primate type.js. So now that compiled, and we can check here in our browser. We see, going to zoom in here a bit. This now holds the DOM that we constructed with our functions here. So now I want to achieve this effect that I can actually swipe between these different screens. So what I'm going to do is make each of these diffs take up the full size of the viewport, and then use CSS view transitions to slide between them. So, of course, in a fully fledged application, I would probably create a separate styles CSS, but I'm just going to create these styles here as part of my index.html style. Exactly. Fix the indentation. And we see already if we hover, HTML like doesn't take up the full space, body neither, and has weird paddings and margins. So I'm going to reset all of this here and say HTML body margin body, what did I say, main margin 0, width 100%, height 100% exactly. And then I am creating a touch typing trainer like monkey typing basically from scratch, and I have set myself the goal to do this in like less than 2 hours and at least optimized less than 100 lines of code. So I'm curious where I'm going to end up with this, but at least my Minesweeper experiment 2 weeks ago was really successful, so I'm hoping I can continue that streak. All right, let's refresh here. We see a few margins vanish. That's already great. And these, now we want to also have these take the full height and width. I like using a CSS feature that's became standard recently or is widely supported, which means that I can nest in my CSS the elements or the children or the way the things directly, how I would otherwise have to like comma separate multiple selectors, or I like just write them out in one line. And now we can actually nest this in CSS, so that's super handy because now the nesting in the CSS actually reflects the nesting in our HTML as well. So yes, all those children should have width 100%, height 100%, position should be absolute, and they all have top 0 and left 0. For that to work, we have to make the parent position relative. Here we go, and we just say overflow hidden right away so that we don't have any scroll bars. So now this looks a bit garbled, which makes sense because now all these layers are stacked on top of each other. So now let's say we create a class that is to slide something out to the left. We call it off left, and we say transform, and again Copilot here, or Codium I should say. It's not GitHub Copilot, it's a competitor called Codium, and it's really good at guessing these tasks. So now I can say off left, and we do something. Let's just again have the LLM autocomplete this. Off right, exactly. this goes to the right, plus 100%, perfect. And now we can say menu. We're going to give this a bool to indicate whether the inactive, whether the menu is currently active, and then we can use the class list function, which takes a list of classes, but actually it's not a list, it's a list of tuples, and the second value in the tuple is a boolean, and if that's true, then it has the class, and if not, then not. Import class list, view lesson, and now we have to pass in actually a boolean here. Oh, that's view menu, not view lesson. So view menu, if the focus is not on menu, then it should be off to the left. And now of course we have to compile this again, and because I don't want to compile this every time, I have a program installed that is called fswatch, and with that you can watch a file or a directory, and then we can pipe this into xargs, another widely supported command line tool to execute another command with whatever it gets piped in. And we actually don't want to use what we get piped in, so I'm just declaring this placeholder, but then I'm never using it, and now I'm just writing out or actually I can just copy this call here again, and now hopefully every time I change the main elm or the primary type elm, we are recompiling exactly. So now I don't have to recompile by hand every time. I just have this little one-line command to watch my source file and recompile this on my behalf every time. So what do we have? Well, it looks still the same because currently we're on menu. So we're going to do the same thing for lesson and bool and the results as well. Inactive class, exactly. Well, let's put this one to the right, and I don't even know what I do with the results yet, so maybe I just comment them out for now. And here, if we're not on lesson. So now I would hope we only see the menu exactly. And so the lesson is still here. It's just slided out to the right. It's transformed. We should see 100% to the right. So that's why we don't see it overlapping the text here. So let's add a button to the menu to start the actual lesson. Button, text, start lesson. So now it should recompile exactly, and if we refresh, we have the button there, perfect. And if I press it, then I want to enter the lesson, so the menu should slide out to the left. So say on click, exactly, clicked start lesson. So that's a new message that I want to send from our HTML here. So that is one of the possible values for message. And I'm going to replace this no-op thingy with click start lesson. And then in our update function, we want to actually handle that case. And now we want to do a partial update to this model record. And the syntax for this is like using the following. So we're taking all the game or the app state of the model as it was before, and we're just replacing one field here, the focus field, and we're setting it to the value on lesson. So that means if I refresh now, boom, now we are on lesson, and it didn't really do the nice transition, and that's because I forgot to add the transition CSS attribute. Have a second for the transform property. So if I refresh now, we have the nice, is that actually visible? Yeah, should be nice. Lesson is coming in hot. All right. So now on this page, I basically want to see large what I want to have to type, and then while I type, progress letter by letter, either green or red, whether I hit the right key or not. So what I want to do, I guess I want to listen to on key press or on key up or something. So let's Google for that. Packages. Pretty sure that's part of the. I mean, these are popular packages, but this is actually the bread and butter of developing an Elm application. Those are packages that are published by the same people who wrote the compiler, basically, or although I'm not sure if that's entirely true, but every time I looked at the sources, Evan, who also wrote the compiler, had also contributed the package. So in Elm browser, we have on key up, and this gives us a subscription. So a subscription is basically saying like this, it's not an event handler that's attached to a specific element or something. It's just attached to the whole application. And where are our subscriptions? 18, go to definition, and currently we don't have any. So let's change this. On key press. No, let's say on key down. That has the shortest time to the shortest delay basically, and we get a decoder because we actually get the whole on key up event from the browser, and we have to decode ourselves what we want to extract from this. And there's a little bit of a caveat with that. And so usually when I use this, I just go to this page and grab this little piece because it's of code. I quickly go over what this is doing in a second, because it basically gives us the decoder. And to have access to the decoder, that is actually part of another package, JSON. So we have to actually add this first. And contrary to JavaScript, where you have npm, or Ruby on Rails, where you have bundler, like an external tool to manage your dependencies, you add the dependencies with the Elm compiler itself. So we can just say Elm install Elm/JSON, and then it tells us, oh, I found it in your JSON file. It's already in the indirect dependencies. I'm going to move it to the direct dependencies, which is exactly what we want. I'm going to relaunch my watcher here. And now we can say import JSON decode as decode. That is just that if we want to refer to functions from this module, we don't have to write JSON.decode. We can also always just write decode like they do in the example. So we're just going to import it the same way so that we don't have to change the code. So what does this do? So a decoder is a function that lets us that tells us how the runtime can decode a JSON into a type that we want. In our case, it's the key type, and that's one that we just created before. So we're distinguishing between two different kinds of key presses. One is where it's a character key, and one is where it's a control key, like the return key or the backspace key. So that's going to be important later. Although I think the return key is actually also just a character. It's mainly for the backspace. So how the decoder works is basically says like, take this decoder, which just looks at the .key in the JSON, at the .key field, and expects the value to be a string. And then it takes a string and then it calls this function with that string. That's why toKey has a signature of takes a string and returns a key. And that just does the distinction between the character and the control keys for us. So now that we have that in place, we can go to our subscription and say on key down, what's the signature? We want to give it a decoder that decodes the key event into a message. So we only have a decoder that turns it into a key. So we have to write another decoder, and I'm just going to do that in place here, because decode.map is basically exactly that. Or is it? I think so, yeah. Key pressed, so this constructor or this function doesn't exist yet. And I think the LSP is not smart enough to derive it for us. No. So we have to create this message. It's key pressed, and it takes one argument key. And it's still not happy. Yeah, because we have to give it some parentheses here. Bam. And now, of course, the compiler is complaining that in our update function, where we deal with all the messages that can be sent from our application, we're not dealing with this new message yet. I'm just going to put here in a placeholder where I'm not doing anything. And now at least the application is compiling again. So that's great. One thing I like to do, instead of having the parentheses, it just, in this case, it doesn't make a big difference, but I just want to show it. We can replace it with this nice triangle lesser than pipe operator. This way I know anything that comes between this operator is part of the argument that gets typed into on key down. Alrighty. So yeah, maybe we just add something now. Like I know one record each key press, obviously. So we are going to put a field here into our application state that's called lesson, and we're going to invent a new type, or more precisely a type alias, because it's also just going to be a record, a struct in other languages. And let's call this property typed. All right, so now I'm going to jump to the next diagnostic, and the compiler is complaining about the fact that our init function does not initialize actually a model completely. So we're going to add our lesson attribute, and it's compiling again, so that's great. And now we're going to go to our view, and to our view lesson function. And we're going to pass in our model.lesson as well. So in addition to the Boolean that tells us whether we're currently looking at the lesson, we're going to pass in the lesson itself as well. And we're going to destructure it directly into the typed field here. And so instead of just text lesson, we're going to put in what we actually typed. So it compiles, but if I reload, it still doesn't do anything if we type here. It just goes into, I have to Vimium, I guess. That's why, but if I type, nothing is happening, because when we process this action or message, the key pressed, we are not actually doing something with the key. So we know key can be one of two things. That's why I want to start right away with a case statement here, or pattern matching, case character C, then we're doing something. And if it's a control character, for now, we just don't do anything. But the interesting case is where we type the character, and I think I want to update the current lesson, so I'm going to do again a destructuring here. I'm picking the lesson from the whole model, but I'm also saying as model so that I can also keep updating the whole model as I did before. All of those are immutable values, so I don't have to worry about accidentally doing partial replacements or something. We always create new expressions in Elm. And yeah, Codium has a very good first guess already. It's just that string concatenation is done with plus plus, and C is a character, so we have to turn it into string. Is it from char? From char indeed first to be able. And I have a few things going on with my brackets here. Model.lesson. No, that's why I destructured lesson so that I don't have to write model lesson the whole time. And that looks better. So now if I refresh and start my lesson and type, we actually see what I'm typing. So that's pretty neat. But of course, we want to compare that with something that I'm supposed to type. So let's add this to the lesson type. So let's add a field that's called expected string. So now again, it will complain about the fact that this field is still missing here. Expecto patronum expected equals, let's just call this lesson 0. And let's just create lesson 0 equals, and we can do multi-line strings, and let's just say we want to have these two import statements as content of our lesson. Sure, add the invert annotation. Are we compiling? We're compiling. Perfect. And now we're going to the view lesson function. And yeah, we're just going to, I think always, we're just going to always display the expected here. ID expected. And that's going to be text expected. Oh, actually we're going to do pre because we want nice. I want the code themed typing, touch typing trainer pre. I don't know why I'd want to do that qualified now. ID expected, text expected, so we have to destructure that as well here, expected. And now we have to import that. Boom. I'm just going to auto format again to keep my sanity. It compiles. Expected typed. So now we should see both the things that we're typing. And now basically I want to gray this out a bit and then type over it. So I'm just going to overlay these two. So let's call this typed. Although actually it doesn't. Oh no, it should matter. So do we have already an ID for this? Yes, it's lesson. So here in lesson we have pre's nested, and pre's we always want margin 0 width. We're just going to fill the screen with this as well. Height. And then we say if this also has the class expected, then we're going to change the color to be, I don't know, a light gray. And we also want these to be position absolute, top exactly, and then we have to say position relative on the parent. So if we refresh and why I would expect this to be a bit, did I save my Elm? Did it compile? Yes. Does it have the ID expected? But it doesn't have the color for some reason. It's the ID, which doesn't make sense. So these should really be classes, because at this level, I'm not sure anymore that there never will be something that's called expected on another part of the page. So I really want to make sure these are the same. So now I can type over this. Blah, blah. All right. That's good. That's pretty good. So now I guess we want to separate. No, now I want to, we see if I press enter, nothing happens. Because I guess that's because enter is a control character. So let's go to our update function, and I'm just going to throw in a debug.log key in here. So this whole expression is still the same type or the same value that the last argument of the two, the second argument of debug log is, but it will also be printed to the console. So let's bring up the console, increase this font size a bit here. So now when we're typing, we see when I hit return, I get control enter. So when I hit control enter, I actually have to append a line break. And now this is getting a bit out of hand to do all of this in here in the update function. So basically I want to say call a new function, typing lesson or the lesson. Now we can also bring this back onto one line, and we create a new function. I call it typing, takes a character and a lesson exactly. So we just call this lesson, and then we can do again a partial update of a record where we say lesson, update the typed field exactly, typed, I asked, still not the right string dot from char, boom, lesson dot typed, it compiles. Now we just have the exact same behavior as before, but we can go back and say like if control key, and so if control key is enter, then we actually want to append a return to \n to our string. So we just do model lesson equals typing \n lesson. So now we should be able, I'm actually not looking at control key yet, so there are probably other keys that are also control keys which now add this, which is of course not correct, but it's just to small steps, right? Import, enter, blah, 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 blah. Wonderful. So now we actually just want to do that if control key is is the enter, I think it said, right? If we hit enter, where's my console? Control enter, exactly. So we can just, I will just jam this in here, I think. No, we do this differently. I just start right away with control a case statement here, and we can also use code strings here. Enter in our pattern matching, and if it's not enter, if it's anything else, then we just return that exactly. Save a bit of space here, so that means so this branch means if it's anything else, it's like otherwise else in other languages. So now it compiles again. I'm typing, I'm hitting backspace, nothing is happening, I'm hitting enter, and we go on to the next line, so that's perfect. So maybe we deal with backspace now right away. What does it say on backspace? Control backspace. Not too bad. So let's copy this, although it's probably something else. Backspace. So what we want to do when we hit backspace, we want to remove the last character we've added to the, what's it called? Typed. So maybe I just do this in place right now, and if it gets out of hand, then I can still refactor it in its own function. Alrighty, so we want to update lesson, and we want to, like this is what I want to do. However, drop is not a function of the string. Module, we have slice instead, and we want to slice from string slice. How does it work? It also works with negative. Where's string? I can just search here actually, string slice. So from 0, yeah, that's the thing. From 0 to -1, I guess. 0, whoops. 0 to -1. And then there's a bracket missing. And of course the string itself. Lesson.typed. Formatting, compiling, refreshing, import, backspace, backspace. Very nice. Very nice. Okay. And now the next step, I would say, I just increase the font size here a bit more. Boop, boop, boop. Now I want to actually indicate with different colors whether the type character was good or bad. And so how do I do this? I think I'm actually going to keep two other text layers, one with all the good characters, where the character will be green, and then the bad characters will be red, and I overlay all of them on top of this expected layer, and I just insert spaces in the respective other layer so that I only have one or the other character show up. So in any case, let's first calculate the expected key. Expected key. So this, we have to keep track of the, well, we have in typed we have our current position. So let's pos equals length from string of lesson.typed. And so expected key is expected at the position pos, basically. So we can say string dot slice. That sounds good. In, and maybe before we move on, I just log this to see if my math was right, because more than often it's not. Expected. Why are you not happy? Because this needs brackets. Boom. Compiles, refresh. I type an E and expected. I think I refreshed too fast. Nope. Why do we not see debug log expected? Control key, because this whole statement I actually want to have here. So let block. Compiles, refresh, E, expected E. And now I'm typing M. And so this is basically always one behind. Oh no, that's not, that's, if I press P, then expected, let's see, I think that's actually good. Like I'm hitting, let's see, am I off by one or not? That's the big question. I'm hitting P. So we hit process the key press, so expected should also be P, yes. No, that's perfect. So basically I want to extend my typing function to also take the expected key. Of course, I have to do this in both instances. And now we go to the definition of typing. And this is actually a string because we used string slice. Expected. And now maybe we rename. We can use the LSP down here to rename C to actual key. Boom. And now, now we can compare those, but we don't really have the means to do something about it. So what I want to do is I want to keep track of two more strings, good and bad. And so good, we just say if those are not numbers, but if it's good, then we actually, if they type the right key, then we want to add the character or the key to the good list of keys, and if not, to the bad list. So let's say then we have list dot good. Oh no, actually we always want to append, because in the case that we mistype, we still have to progress the layer with a space to not have that overlay with the wrong character the next time we do type a good character. So we say lesson dot typed, no, that's lesson dot good plus plus. And so if it's right, then we actually add expected, and otherwise we add a space. And maybe we just, for consistency, turn this into a string as well. And then we also don't need to do the thing. And here we just turn this into a string. And then we do the string from char here. 104. does not have a good field. That is correct. Bad. All right, so let's go to the definition of lesson and add a good string and a bad string. Boom. And now in our view lesson function, we want we don't want typed, we want good and bad. Good and bad. And now we have to destructure them from our lesson as well. Good, bad. And now I'm going to add the CSS, the colors for those as well. Good is going to become a nice mild medium light, I don't know, be green. And bad, there we go. And does it compile? It does not compile. Why not? 109. Why are you unhappy? Unknown operator. Ah, yeah, because the operator for not equals in Elm is /equals. And now I'm missing these fields when I'm initializing my model. We don't use that anymore. Unused. Yeah, sure. Typed. Expected. Good and bad. Initialized with an empty string, and we're compiling. And I start to type import. Ah, that's not really green. XXXXX. Nice. The red can be a bit redder and the green can be a bit less blue maybe. So let's go back. RGB. And I said I want more. Let's make this a D. D. Boom. Start lesson. Import. Nice. That's pretty neat. The only problem now, when I'm backspacing and I'm typing, we are not backspacing on our good and bad fields. So let's go back to our update function here. I think I'm just going to remove this debug statement for now. This we don't need either. Boom, key. So if we have enter and backspace, those are both cases that we need to update. Although enter, I guess that's okay. Maybe we can, if we type to the end of the line and then we don't hit enter but mistype like a space or a letter, I want to show a little Unicode return symbol in red that I was supposed to hit enter. I think that's a nice little UI tweak. Unicode return symbol. There we go. Just going to grab this from here. Oh yeah, but now I have to say led to bad if actual key is not equals expected, then if actual key exactly is return, then we're going to, whoops, give this guy, but I think we also have to give the return. Otherwise, And if the right key was pressed, then we still have to add and it's a return, then we still have to add a return as well. Ah, yeah, this is actually actual key. And so if enter was pressed, then we just don't show that. And now we can replace what we add to bed into bed. Does this make sense? Let's see. Start lesson. Import browser, and now I'm hitting X. Boom. I don't want to see the X. I want to see weird. What happens if I actually hit the line break? Browser enter. Import. Okay, so this is good. Just so if and the actual key. Okay, let's add some debugging again. Good old printf debugging. Actual key is actual key. Start lesson. Import browser. And I'm going to hit X. Actual key is X. And what is expected? Why is... Ah, no, if expected is... there we go. Start, import, browser, X. Wonderful. And now if I continue typing, that's not why it should have been... It should have added the line break nonetheless. Ah, no, it also needs... We need to add the line break to... yeah, so I guess if I type the... If I type the wrong letter after the wrong line break, then it should look good. So X, exactly. We just need, even in the case that we hit the wrong line break, we also have to add the line break to the good layer. So we are going to calculate both of the things we're adding to the respective layers at the same time. So if expected is a line break, then we want to add the line break to both. If the expected key is not a line break, then we're going to add a space. And if we... Now I guess it's time to actually switch these branches to make it a bit less confusing. If we hit the right key and expected, well, in this case it doesn't matter, but let's just stick with it for consistency. If we want also to add a line break to both. And if it's not a line break, then we want to add the actual key to the good layer, actual key, and a space to the bad layer. All right, and now we're going to replace this with too good. It's too good to be true. Bam, compiles, refresh, start, import, browser, X, import, nice. All right, now I'm hitting backspace and nothing is happening. So we have to work that into our update logic as well. Which basically does the same thing for all three fields, not just typed. So let's just duplicate this. Good. Good. Bad. Bad. Should compile. Start lesson. Import. Oops. Ah, yeah. That's also not correct. It should, of course, use the letters, what's actually expected. But at least I can import so and can backspace again. So that's already great. But I said if I mistype, I don't want to show the character that I actually typed, but the character that was expected. So if expected, if actual key, so where's the else for this one? Else, interesting. It's here. Actual key, expected. Compiles, refresh, start, and this is wonderful. I'm just typing access here, so that's exactly the expected behavior. All right. So this is pretty good. I think to finish the prototype, what's missing is like, if I type to the end of this, I want the lesson to finish and automatically transition to the results screen and show me how much time I spent, what's my word per minute as a minimum stats here. So let's do that. So that means instead of when I start the lesson, directly starting the lesson, I should first record the current time. And time is another package that is also, but pretty standard. Time, all the packages that are under the time provider, or I don't know what's the official name for this. Like this is the namespace or whatever you want to call it. Time is Elm time is also something super stable, provided we go to the source, and then we could look at the commits. Like we see, it's all from the man himself. It's super stable 6 years ago, so I have no problems depending on that. Using the Elm compiler again, add Elm install Elm time to add my dependency. Yes. And now we can use the now function. So the now function gives us a task. And so task, I think to actually issue the task, we have to turn it into a command. And task is part of the core. Perform, and there's a method perform that takes a function that turns something of type A into a message, and a task that produces this A and turns all of this into one command. So basically, exactly, it's just the pattern that's shown here already. We want to perform this time now task, and then new time is basically a message that we have to invent. So let's maybe start there first. We want to go to definition. And say like got time to start. And so now we want to know what this A is basically, because like how do we get the time? We can go back to time or not, packages, boom, go back to the time package, to the now function, and now we see gives us a task that produces a POSIX. So POSIX is a computer representation of time. So let's just go for that for now. POSIX. And for some reason, the LSP has not yet realized that we have added this package yet. So we just say it ourselves. And now the compiler is unhappy because it says we are not dealing with this new message yet, which is correct. So let's go to our update function and let's just add this right here. And we're just, what are we going to do? What are we going to do? We're not going to do anything. It's command dot none. Or no, let's actually, what I want to do is I want to record the start time, the time when the lesson has started in the actual lesson property. So we're going to, again, extend the lesson type here, or the lesson record. Started at is a POSIX, exactly. So let's go back to the update function, and instead of just doing nothing, we're going to update the lesson. And the lesson, we're just going to take the old lesson and update the started at with the given time. Now a bracket is missing, a bit of space doesn't hurt either. Then now we are missing in our init function to actually initialize this new field. So let's go there. Started at equals POSIX millis to POSIX. We don't have a time yet, so we're just going to initialize it with 0. We're going to import this function. All right. So now, actually, do we do something with now already? I don't think so. No, because when we start the lesson, that's when we actually want to do the thing. We're actually going to go one step back to be able to do 2 steps forward. So we're not, and when we click the start button, we're not going to want to change it right away to the lesson. We just want to ask for the current time. So we're going to say task perform, and we're going to call this new message, or create this new message exactly when we got the time, and now we say time now, and we want to import the task module to be able to do this. And now when we get the time, we want to focus on the lesson exactly. All right, so this compiles again. It should feel exactly the same. It's just that we... All right, all right, all right. Good stuff. We have the start time. So now we can actually transition to the result. Maybe I shorten the example a bit so that I don't have to type as much. Lesson 0. Import. I'm just going to do this one word here. So when I hit the T, I basically want to end the lesson. So basically when typed has the same length as expected. So again, this should happen automatically. So we're just going to do this after we processed our key pressed event. So that would be here. So yeah, let's just say, what do we say? Check finished. Let's create a new function. Check if finished. And let's say it takes a model and updates the model and returns a new model. And again, the LLM has a very good guess. That's a bit too simple though. So it's if length of this typed is length of expected, then no, we focus on results. Wonderful. And now what we can do after we've calculated we have this big case statement here which does different things based on what key we've pressed. And after we've done all of this, we want to do check if finished. And so now I could, of course, again, put my brackets around this, but again, this is very hard to read, so I can just use the small arrow. I was usually at least. Yeah, because yeah, that's also actually wrong. So because again, when we finish the level, we have to ask for the current time again. So we have to use the task, the time.now function again, and issue a command. So we just, all of those branches return command none anyway. So I'm just going to remove this from all of these branches. So now we just have a model, and now check finished just takes a model, but it can also return a command. So here we do again task perform, got time to finish, and we say time.now, and we close our tuple. And in case that we're not finished, we are just returning command none. Some format indenting, and of course it doesn't. I just made up this name, so we also have. And this time the LSP actually knows what we want to do, so we can create the missing union constructor. That's what one of these variants of these union types is called. Can create this for us. And now, of course, again, our update function complains about the fact that we're not dealing with that yet. So let's see, got time to finish, time. And now what are we going to do? Now we're going to model, focus on results, exactly. And yeah, basically we don't need to do this here. We just return model because the actual processing of the time happens later. So where was I? In the update function. I'm not doing anything with the time yet, but we needed to calculate the actual results, obviously. Does it compile? It compiles, and I'm curious what happens when I actually get to import. Nothing. Interesting. Class is nothing. I would have expected that we fade out the lesson. But maybe view. First of all, we should bring back the results. And results should have a similar. And maybe we do again, we deconstruct here the focus so that it's a bit clearer when we call this stuff. Let's go to the definition. So this takes a bool, inactive, class list, and the results, I don't know, of right, sure, that's the right direction. I'm missing the opening brackets for the list here. And now I'm missing the closing brackets for the attributes. It compiles. So now results are off to the right, so that's good. And if we type import, nothing happens because check if finished. Why? Length typed. Let's debug this. Let underscore equals debug dot log, check if finished, and now we can just write an arbitrary expression in here. Let's debug these two lengths of these two strings. The syntax highlighting looks weird, but it says it's also not logging at all. I'm curious. Do I have to do a hard refresh, or what's your problem? Ah, no, there we go. 2.6. Ah, I think I'm only updating good and bad. Oh no, 6.6 results. There we go. I think I just didn't refresh properly. Why is this feedback so weird? Huh? Success, it compiles. What are the messages that we're receiving here? Check if finished should be called if length. Got time to finish. Ah, I'm only calling this. That makes sense. On a control character, which does not make sense. I want to call it on the whole expression, of course. On the whole, not only when we press control characters, but also any of the normal keys. Did it compile? Yes, it did. Refresh, start. Ah, there we go. Boom, results. Wonderful. Okay, now we just have to calculate the actual results. And then I think we're in a pretty good spot. So, got time to finish. So maybe we just say calculate result from time and model. And now we create this function, calculate result. What are my arguments? It's a POSIX, and it is a model, and it returns a model. Ended, end time exactly, model. And so what I want to write in the end is model, and I want to set a result here. And we don't have a result field yet on models, so we're going to change that. That's just going to hold the last result of the previous lesson, and we don't have a type for that. I'm going to create a new type alias here. And result is really a bad name because result is also a type name of a type that's in the standard lib. So I'm just going to results to not have to deal with this. Time elapsed is a good starting one, I think. Elapsed. Or maybe we just call this seconds elapsed. That's going to be a float. And then we have words per minute, which is also going to be a float. And now it will complain about the fact that our init function does not, let's just say debug to do. It should complain about the fact that we're not initializing this. Yes, that's the error I was looking for. So now we also have to initialize our result. Second elapsed 0. Exactly. We're just going to initialize these with some nonsensical values. And now it compiles, but I know I have a debug.todo. So that's basically a way to, like I just wanted to get rid of the compiler complaining about this line, but when we hit this at runtime, it will crash, obviously, which is obviously not great behavior in production. And that's why when you compile an Elm application with optimize to optimize it for production, you see here in our console, it also tells us, no, it's compiled in dev mode. And so when we compile with optimize, then we get better asset size, better performance, and also it will just not compile if there are any debug statements left in the actual code. So now let's calculate the actual result. So let's elapsed, and then we're just going to say, whoops, where am I? What am I doing? Pressing tab for some reason. Elapsed. Seconds elapsed, I called it. Okay. Seconds elapsed. Seconds elapsed. That's one feature that I'm missing. The shorthand assignment that, for example, Rust has, to not have to repeat myself like this all the time, but it's a luxury problem. Seconds elapsed. So in our model, so basically like what I want to write is, yes, exactly that basically. So, but end time and started at are both POSIX, which cannot be subtracted because they're not a number. So what we're going to do is we're going to convert them to millis. POSIX to millis, exactly, but I don't want the qualified version. End time, and we're going to subtract POSIX to millis. POSIX to millis, lesson started. Those are ints though, I believe. Oh, it's not happy. I have to import this function, and now I can see these are ints. That is fine as well. And then I have to convert them to floats, to float. And then I can divide them by 1,000. And so that should work. And now words per minute is words per minute typing calculate. I wanted the formula, but I guess I can also Formula. So I think uh, 5 characters always count as one word equals 5 keystrokes. Yeah, so it's total words typed divided time in minutes. So minutes is exactly total words typed equals yes divided by 5. We have to turn this into a float to float. Bam, and now we can calculate. I think it guessed right. Words type, boom. Type mismatch. Something is off, float, but it should be a model. Yeah, that's correct. So this is actually the result. Did I call it results at least? And then we just update the model. Of course, I did not call it results. So can we rename it from here? Bam. Statically typed language. Elm renames everything at the correct places 100% of the time. Bam. All right. So now that the lesson ends, we have our WPM and the seconds elapsed. So if we go to our view results function, we can say, I don't know, this is a H3, boom, then we do a diff text time, total time, and this is text from float, and then of course we want to have results here, and we're going to destructure them right away into exactly that. From seconds elapsed, look at this, and this has to be a text node, of course. Boom. And so results, ID results, sure. View results is not called correctly. That is true. This also takes model.results. This compiles. Let's refresh. Start lesson. Import. Come on. Nothing is happening. This already worked. What's wrong? Import. Okay. Let's go back. Am I even calling the function calculate results? Got time to finish. I'm not focusing on the results. So that's an easy fix on results. Exactly. Import. Bam. Total time. 38 words per second. Not bad. Not bad. All right, so that's obviously there's one or two things missing to be on par when it comes to features and UI with monkey type, but I think like the core of the problem I demonstrated well that it can be solved. Now is the question, of course, how many lines of code? And like I find this always a bit tough because if we just look in here, we're at 250, so it really looks like I missed the mark by a lot. But this is mainly due to the fact that the default formatter or the formatter, Elm format for Elm source code files is it likes to have a lot of white space. For example, you see there's always 2 lines of space and like between the branches here. So let's just run. I'll keep the watcher to make sure I'm compiling, but I'm just trying to golf a bit here and try to get the file a bit closer into the desired range of lines. So I'm just going to bring up a new shell here where we can call dialog. So that's the if people talk about lines of code or optimizing them, that's usually the tool they use to measure this. So currently we're at just shy of 200 lines of code. So this already ignores blank lines, for example. So I don't need to optimize those. But now I'm basically, what I'm going to do, I've already formatted. So there's no unused code at least, I think. Yeah, no diagnostics. Otherwise, LSP would tell me if I have unused code and could get rid of that for me. But what I can do is like, I can just be a bit more opinionated, or like I'm not using the Elm formatter and I'm just going to squeeze out a few more lines. Or do I start with that? No, actually, the first thing I'm going to do is get rid of the type annotations, because that's also a big point of criticism from people who prefer dynamically typed languages, like, you have to write all the type signatures. And in fact, in Elm, you don't need to write any type signatures for your functions at all. And that's why I want to keep running the watcher here that keeps compiling our program. So the first thing is I'm going to remove all the type signatures. I'm going to use the global command in Vim to find all the lines that start with a word space colon, because that's the easiest way to identify type signatures. So let's say A to Z, A to Z, at least one. Yeah, and beginning of the line, space, colon. So now we have selected all those lines basically, or it will act on all those lines, and now I can give it the D command to delete all those lines where this expression has a match. Bam. And I think we just need one, which is for the init function, which declares what type the init consumes. Because we have the underscore here, the compiler cannot deduce. We're not using it, so something that's not used, it cannot infer a type for. So I'm just going to write the annotation here and say like, this is, can I do that? Although, can I do that? Let's see. Can I do this? Model command message. And I think now it won't complain, or let's just say. All right, so it compiles again. I removed all but one type annotation. If we run, so we just got a bit more than 10 lines squeezed out of this. The next thing is we also don't need aliases. So all these alias declarations that the compiler can derive by the fact how it's used. Like every time we have an int, we use to float or to string to convert it into another type. So just by the use, it can deduce these types. So I'm going to remove all those type aliases as well. So is there still alias somewhere? No. And now, of course, it complains about the fact that we don't have model here. I don't know if I can just treat and just write. There's an unknown export. You're trying to expose a type named model. Am I though? Yeah. Oh, I don't know. Need to be exposing any of these. I can just export main here. And now we like the M compiler wants us to always use the most narrow declaration of a type that we can add. So it's I tried to get away and just use a type variable here, but that doesn't work. So I actually have to write this out. But actually I don't have because I just can let the compiler or the LSP infer that for us. So we can just write the raw types here, basically the unrolled alias here. So now it should work again. Oh yeah, those are actually not ints, those are floats. And here is still, now it inserted again because it doesn't know what type of values we consume in our init function. And now it compiles again. So we should still be at the same number of lines of code. No, even less, because, oh no, that's without the type aliases, I guess. Yes, so we got another 16 lines out of this. So and now we can, the last step is, what we can do is we can squeeze out by just not so nicely indenting some of those expressions here. So that's, I would argue, this is definitely borderline. So maybe we split those up, good and bad. This can go on one line. And then you can also, of course, say like, okay, I'm not respecting the way that parentheses are broken apart. Then we only have these 4 messages, that's something that I really like about L messages. You have at the top level, you see really all the things that can happen in your app. It's not distributed about components or something, but of course you can break it down. But you always start from the top level message to see what are all the things that can happen in my app. Here again, very generous indentation here. We can just bring those onto one line. Those is easily one line. And like even the branches and the value, these can just be one line. And here there's not a lot happening here, so we can just inline those. This is also just one line, and you can see really how this crumbles together if you don't care so much about the default formatting. Whoops, that was too much. So yeah, those can also go on one line. Those anyway. Boom. This is a bit nasty. Maybe this could be actually broken down into one case statement. I look into this as a means of last resort. Let's go like this here. This can also be on one line. This can go on one line. Good, bad here. Here our key type. This is all, and I could even like key decoder. I could inline this function directly. One could argue that makes the code even more readable if I would use key decoder in the place where it's actually used, because we only use it once. So where are we? 180 lines. So let's see, I think I can squeeze out another 20 lines. It should be possible. So let's see where we use key decoder. That's here. So let's just inline this directly. Boom. I have a function to toggle the diagnostics so that the LSP doesn't complain as much. And like, can I rename? No, I cannot rename that. Okay, let's say decode. We just write this as D. And now we can just write d.map. Then this is actually a bit, it's not too unreasonable to put this into one line. All right. And then I said I want to squeeze this. So that's going to be an interesting one. Does it still compile actually? No, I already broke the code. Key decoder. Ah, that's just because this assignment is left over here. Bam. So now we are at 117. Perfect. All right. So now we will rewrite this into pattern matching. It's actually an opportunity to show a nice way to write an Elm that is not readily available in other languages that don't support pattern matching at the same level. So I can create a tuple in place. So the first thing I'm interested in is if we actually hit the right key. And then the other thing I'm always comparing against if expected is a line break. So I'm going to put this as a second value in this tuple here, expected. And then I think it might actually be more readable than this weird cascade of ifs and elses. So first in our contraption here, we deal with the two cases where we actually hit the right button. So let's write this out. We have true and we have an enter, and then we do something, and the thing we're doing is this. And if it's not enter, but we hit the right key, we can use the underscore as a placeholder for all the other cases, then we're doing that thing. So let's put that in. And so if we did not hit the right key, and the right key was a line break, what are we doing then? Then we want to do this thing. And in any other case, false, we do this. And you see, not only is it much shorter than these two nested if statements, it reads nearly like a logic table. So that's really neat. Does it compile? It compiles. What is our lines of code? 113. So now it becomes really like now it's just to make the point that it's possible to bring it down to 100 lines. So I don't know where I would squeeze those out. I could map over a list here and squeeze these onto one line. Let's see, what else do we have in here? Well, we don't need to import string. String is imported by default. So we can just go to from float and length. We can just say replace everywhere from float with string dot from float. Oops, there's an S missing. And replace length with string dot length. Boom. Now we got rid of one other line. It still compiles. Task we have to import. The rest we really don't really get around. Here we have one completely. Oh, there's still this had lesson. That was very wasteful, I would say. So now we're at 108. Now we just have to squeeze out. I mean, that's also waste of time, space here. Boom. 3 lines. Feeling pretty good. Feeling pretty good. Do we work with position here a lot? Yeah, well, twice. Yeah. I mean, this can easily be inlined. I mean, those can also go on. This doesn't really add. Da, 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 da. Da, 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 da. Yeah, those. Boom. Subscriptions, sure, main, whatever. We can bring the closing bracket of any list always on the last line. And I think there we have it. A touch typing trainer with 3 pages and indication and calculation and everything in less than 100 lines of code. And less than 2 hours of time. So yeah, all in all, I'm pretty happy with this result. I hope you enjoyed it. I will share a Git repository where I also host the code. Both the versions, the annotated version and the optimized version. I will share the link in the description. And yeah, if you like this kind of, if you're into this kind of entertainment, I hope you will tune in the next time. I don't know what. I should really make a plan of apps that I want to do so that I can leave a little teaser, but I will look what I will work on next week. So thanks for stopping by and hopefully see you next time. Bye.